Demo, we will show how to use semantic technologies to combine information from multiple sources and present it in an OLAP cube. An OLAP cube is a multidimensional presentation of aggregate data. Multidimensional means that the cube shows information sorted in many different ways, e.g. by race or gender of a person. Aggregate means that instead of individual data, like what is the blood pressure for John Doe, it instead reports totals or averages. What was the average blood pressure for black males, black females, Caucasian males, and Caucasian females, respectively? Semantic technologies allow us to integrate data from several sources and treat it as if it came from a single source. In this demonstration, we will show the steps needed to take such a federated data stream and prepare it for presentation as an OLAP cube. The demo comes in 3 parts, corresponding to 3 different classes of user performing 3 different functions on the data. The first user is a data modeler. This person understands abstractions in the information and can interpret data from the raw data streams. This person will use a technical interface to describe these abstractions and make them ready for the next user, which is the cube designer. This person knows what aspects of the data have business importance for a particular work process. This person will use a simpler interface to describe how the cube structure relates to the data abstractions from the previous user. And finally, the information consumer will browse the information that is formatted according to the cube design using standard OLAP presentation tools. We now begin with the first step of the demo, where the data modeler will build the abstractions to start the process. In order to understand the task faced by the first user, the data modeler, we're going to begin by taking a brief look at the raw data stream coming from the information sources. In this case, we are looking at data coming from the health centers in the Houston, Texas area, although the approach is actually amenable for many different data sources as well. In this data, we see some recognizable things like initial temperature, values, units, and the method by which it was measured, or initial blood pressure with indications of systolic and diastolic. While this information is clearly present, this is not the best form for humans to understand the information, nor is it a good form for federating information from multiple sources and viewing it in a single place. So the first step of the process, which is fully automated by a process called XML to OWL, developed by the University of Texas, we process this XML input, and the result of that in the web ontology language of the semantic web, called OWL, is a set of descriptions of the kinds of data that's there. So for instance, here we see that there is a description of pain, a description of a pain patient report, and that these are related to a single notion of pain. Now, the data modeler is the one whose job it is to understand these relationships and to look into them closely to see what they actually mean and record this for future users to understand. So, for instance, if we look at pain, we see that even though the name is simply pain, that it is used actually in a context of a patient's nursing chart, and in particular for a report of gastrointestinal pain. So while the name seems to be simply pain, what the data modeler can see is that in this context it's actually a particular kind of pain. So for this reason, our data modeler has decided to use this notion of pain in their definition of abdominal pain. So the word abdominal pain is understandable to users downstream. It's also amenable for federation amongst multiple sources. There could be different ways that abdominal pain is represented in different sources. The data modeler will specify that all of those are what we mean by the abstraction abdominal pain in this model. So the data modeler will continue in this fashion to describe meaningful and useful abstractions over the input data. In the second part of the demo, we'll show how a cube designer can take advantage of the abstractions defined by the data modeler in the first phase to configure an OLAP cube that will answer questions that are of importance to their business process. We begin by creating a file that will hold the configuration for this example. I'm going to call it cube2. And we're going to import here the abstractions that were defined in the first phase. They're in a file called dimensions.owl. And the data stream itself, since at this point we're going to be creating a report of the data. Then we're going to run a semantic web inference process over this data. What this process does is it takes the data and classifies it according to the descriptions of the abstractions that were done by the data modeler. This brings information from multiple sources and treats it all as if it's in one place, classified by the single set of abstractions that the data modeler defined. Now, we don't expect that the cube designer is going to have the detailed modeling expertise of the data modeler. So instead of having the cube designer use the engineering interface of Top-Grade Composer, instead the cube designer can use a web-based interface that is somewhat simpler, that they've called Top-Grade Ensemble, whose purpose is to allow them to create configurations based upon the models that the data modeler has produced. So what we'll do, we'll begin by creating an instance of the class cube. This is going to be describing a cube here. We'll call it cube2. Now, a configuration of a cube really has two parts. There's the dimensions and the measures. So we're going to create, in this example, 3 dimensions: acuity, gender, and sign. And then we're going to create 2 measures. These are the things that the OLAP cube will report on. One is called systolic, and the other is called diastolic. That gives us the structure of our cube. Now we want to connect this cube to the abstractions that were defined by the data modeler. So we're going to start with acuity. We're going to connect that to an abstraction in the tree, and the one that we're going to connect it to is called encounter by acuity. And then we're also going to do the same for gender. We're going to connect that to person by gender. And then finally we'll go to sign, and we'll connect that to encounter by sign. These are all abstractions that were defined by the data modeler in the first phase. Now, to describe a measure, we have a slightly different configuration form. We need to describe the source of the information, and so for systolic, there's a systolic value. The aggregate type, there are 5 aggregate types that our OLAP cube knows how to manage. These are fairly standard: count, min, max, average, and sum. In this case, we're going to take the average systolic blood pressure. And finally, we're going to define which entity in the OLAP space this is describing, and it's in fact the encounter. The diastolic measure is processed in much the same way. We will define the diastolic measure as where the value comes from. It's going to be an average diastolic blood pressure, just like we did for systolic. And again, this describes the encounter. Now, the cube that we've just configured in Top-Grade Ensemble is also available here in Top-Grade Composer. So if we look here, we see that one cube has been defined. It's called cube2. It has 3 dimensions: acuity, gender, and sign, and 2 measures: diastolic and systolic. Now, this information is currently in the form of a semantic model. In order to make it into the form that is amenable to a standard OLAP processor, we're going to use a script that has been written for the purpose of making that conversion. The first step of the script reads in the model, so we're going to put in the model that we've just defined. And as you can see here, the script itself is in the form of a series of operations, one dependent upon the other. There's only certain operations that we will actually need to execute here. In fact, most of them we don't need. We need the ones at the very end. The dimension tables that would describe the dimensions, the join tables that will connect those to the data tables, and then the measures that will be the actual systolic and diastolic blood pressure. And then all of this information is written to our local disk, which we can see here in the OLAP output folder. So here we see, for instance, the encounters table where the measures systolic and diastolic are stored. We see a table for acuity and one for signs. This is the one we need. The signs, we actually see all of the signs that appeared in the data. So we see abdominal pain, cough, respiratory sign, gastrointestinal sign, and so on and so forth. This is in a tabular form that is amenable to OLAP processing. In the next step, we will send these tables to the OLAP processor to form a cube from which we can actually have reports so that the final user can get the information that they need for their work process.